I want to find the third degree Taylor polynomial given the function is 1 over x, centered at x equals 2. So in general, the Taylor series is going to be the sum from n equals 0 to infinity, nth derivative of x at x equals a, rather, and then the quantity x minus a to the n over n factorial. We're interested in the third degree, so we want to go up to when n is 3. So we'll go from n equals 0 to 3, and then we'll look at the nth derivative. A is where we're centering it at, which is 2, and then times x minus 2 to the n over n factorial. Okay, so for this, we're going to be looking at taking 3 derivatives. So f of x is 1 over x. That means that f of 2 is 1/2. F prime of x is negative 1 over x squared. So f prime of 2 is negative 1/4. The second derivative now is 2 over x cubed. And when I plug in x equals 2, I get 1/4. And then we can look at the third derivative. That's going to be negative 6 over x to the 4th. And then plugging in x equals 2, we get negative 3/8. Okay, now we can put these all together. What we just found was this term right here, or this coefficient. So that's going to be for these in the stars. We have to divide them by n factorial, and then multiply by x minus 2 to the n. So first, we start at n equals 0. So this is the original function, f of 2, which is 1/2. And then times x minus 2 to the 0th power over 0 factorial. Plus, now we're looking when n is 1. That's the first derivative at x equals 2. That's negative 1/4. X minus 2 to the first over 1 factorial. Now we're looking at n equals 2. That's the second derivative. So that is 1/4. X minus 2 squared over 2 factorial. And then finally, the third derivative at x equals 2. That is negative 3/8. X minus 2 cubed over 3 factorial. So now this is a third degree polynomial. All we have to do is just simplify. We have 1/2 minus 1/4 times the quantity x minus 2 plus 1/8 times the quantity x minus 2 squared minus 1 over 16 quantity x minus 2 cubed. And so this is my third degree Taylor polynomial.